Hello, this is mathjazz from Almost Cool. This is the fourth video in our series of videos on optimization examples. Today, we are going to talk about a cylindrical can, but as opposed to in example 3 where we talked about the area of a can, the surface area of a can, today we're going to talk about the cost of a can. So, in this example, we suppose that the material for the top and bottom of a cylindrical can cost 0.02 cents per square centimeter, and the material for the wall of the can costs 0.03 cents per square centimeter. We want the minimum cost of the can, and we want to find the dimensions of that can. Here's a diagram of a can with height h and radius r. We recall the formula for the volume of a cylinder. Volume equals pi r squared h, and plugging in 1000 for volume, for V, and solving for h gives us h equals 1000 over pi r squared. Now we must find an equation for the cost of a can. So the cost of a can of radius r, with the volume being 1000, is equal to 0.02 times 2 pi r squared. That is the cost per unit area of the top and the bottom times the area of the top and the bottom, plus 0.03, which is the cost per unit area of the sidewall, times 2 pi rh, which is the area of the sidewall. If we add those two terms together, we get the total cost of the can of radius r and volume 1000. We simplify and get the cost of the can of radius r is equal to 0.04 pi r squared plus 60 over r. Like any of these optimization problems, we take our cost equation and we take its derivative, set it equal to 0, and solve for r. So C prime of r equals 0.08 pi r minus 60 over r squared. Setting that equal to 0 gives us 60 over r squared equals 0.08 pi r, which gives us that r equals the cube root of 60 over 0.08 pi, which gives us that r equals 5 times the cube root of 6 over pi. Now we plug r into the height and cost equations to obtain the dimensions rh and the cost. So we plug in r to the volume equation, solve for h, and we get that the height is 40 over 6 to the 2/3 power times pi to the 1/3 power. And we plug r equals 5 times the cube root of 6 over pi into the cost equation to get that the cost is 3 times 6 to the 2/3 times pi to the 1/3. So the dimensions of the can are height 40 over 6 to the 2/3 times pi to the 1/3, radius 5 times the cube root of 6 over pi, and the cost of the can is 3 times 6 to the 2/3 times pi to the 1/3 cents. Contact information is on the screen. Thank you for watching this video. I hope you're having fun learning calculus, and I hope you have a great day. Goodbye.